Hello friends, in this video we will try to understand that what are solid principles and why we are using this. So solid principles were introduced by Robert C. Martin. Okay, and what is a solid principle? So solid principles are set of design principle that provides guideline for creating maintainable and scalable software. Okay, so this is the definition of solid principle. That means while designing the software or application or any individual interface, we follow these guidelines so that we can easily maintain and scale our code in the future. Okay, now we will understand that what SOLID stands for. S stands for single responsibility principle, O stands for open closed principle, L stands for Liskov substitution principle, I stands for interface segregation principle, D stands for dependency inversion principle. Okay, now we will understand what is single responsibility principle. So let's go to the another slide. So single responsibility principle state that a class should have only one responsibility or only one piece of functionality. That means suppose I have created one class here. You can see this is the report class. Inside report I have created three different methods: generate report, send email, authenticate users. By seeing this class only, you will observe that I have created three different functionality which is no related to each other. Report is fine, like according to the class, generate report is fine. It will do all the activities related to report only, right? But send email, authenticate users are irrelevant. That means it is violating the single responsibility principle. So how to resolve this? What we will do, we'll keep generate report in the report class. Rest other things like we will just separate in the other classes. Okay, so for send email we'll create the other class, and for authenticate user we will create other class. So let's go to the code and then we will understand. So here you can see that I have created one report class, and this is console application. So in report class I have created three different methods, right? Generate report, send email, and authenticate user. So what we will do, we'll keep this generate report in this report class only, and send email and authenticate user we will just move it from here. Okay, so for send email I have created one send email function class. Inside that I'll move this send email functionality. Okay, so I will just remove from here. Okay, similarly I'll just created like authenticate.cs class, and inside that I have created I've just moved this authenticate user method inside this. Okay, so I'll just remove from here. Okay, and how we are going to call this? So for that I have created one program.cs class, and inside that I have created one main class. Okay, so I have just created one object for report class, and inside that I have just calling this method by using this report. Similarly for send email functionality also we can do that. So for that, like what we will do, we'll just create one class send email function and equal to new send email function, and using send email function we'll call all the methods. Okay, so you can see here, right? What I'll do that, I'll just write one console here. Okay, similarly like how I have write for report. So similarly I'll just write here. Okay, okay, now what I will do, I'll just start this application. Okay, here I'll just pass one variable, just pass abc@gmail.com. Okay, and what we will do, we'll just print this method. So what I'll do that, so now I'll start this application. We'll see. I'll click on continue. See the output, right? Logic to generate the report and logic to send the report via email, whatever like we have passed here. From this, like we are printing the value abc@gmail.com. I hope you have understand what is single responsibility principle. Now we will understand what is open-closed principle. So open-closed principle states that software entities like classes, modules, function should be open for extension but closed for modification. That means we should be able to add new functionality without modifying the existing code. Okay, so I have just taken one example like logger. So here I've taken one example of logger class where we are trying to capture the logs in the different files. Okay, so we are just trying to capture in the files, then console. But what is happening here? We are just violating the open close principle. So suppose like right now I'm just capturing for the log to file and log to console. After some days, like I have to capture in the database, right? So again, I have to write one method here and then I have to write the logic to capture in the database, right? So this is violating the open close principle. So how we are going to resolve that? We will use interface to resolve that. Okay, so I have created one interface here, iLogger. Inside that I have created one method, or you can say, right, signature like log. And after that, what we will do, we'll just create different classes. So suppose I have just created 5 logger classes, right? Inside that I'll just write the method and capture the log. Similarly, we can write for the console log also, right? We can create a console log class, and inside that I'll just implement the log. Okay, similarly, like suppose I need to capture in the database, right? So again, I'll just create one database method here, and inside that I'll use this interface, and inside that I'll write a method to capture the log. Okay, so let's go to the code and then I'll show you. So initial thing what I have done that, if you'll see that I have created one logger class here, right? Inside that I'm just capturing the log using this log to file, log to console. So suppose again I have to capture in the database, then I have to write one another method here, right? So this is not correct. So for that what I have done, I have created one logger. If you'll see that you have just created one iLogger interface here where I have just created one unimplemented class. Okay. And after that, what I have done, I have just created different kinds of class here. So for console, I have written one console class I have created, and inside that I have just using this iLogger interface, and then I'm just implemented this logger method. Okay. Similarly, for like file logger also, I've just called this interface, and inside that I'm just implementing this log method. Again, for the database also, like I can use that. I'm just using this iLogger interface, and after that I'm just using this log method. So how we are going to call this in the main method? So this is my main method. So here what I have done, I have just created one instance of the logger class, right? So I'm just calling this file logger, right? And after that I'm calling this method. So hello from file logger. Similarly, what we can do that, I'll just create for the database also. So similarly, like where database equal to new mylogger library dot database logger, and after that using this database I can call this. Okay, hello from database, I'll write that. Okay, now let me run this application. So now you can see the output, right? Hello from the file logger and hello from the DB. Okay, so what I have done here, I'm just passing the input here, and if you'll see that, if you'll go to the database, right? So whatever like input is coming, I'm just showing this. I'm just showing in the login to the database. So this is open close principle. Now we will understand what is Liskov substitution principle. It states that object of derived class should be able to replace object of base class without affecting the correctness of the program. That means we need to follow the base class contract every time if we are using in the derived class. Okay, and we can avoid throwing any exception from the derived class which can hamper the behavior of the base class. Okay, so just remember these three key concepts. So one is the base class, derived class, and method overloading. So if you'll see that in the base class, I have created one class, database connection, where I have implemented 3 methods. Like one is for connect, second one is the execute query, and for another one is for disconnect. So we have the different kind of database connection, right? Like we have the SQL database, we have the Oracle database, we have the Teradata. So for everything we have the different logic, right? So suppose if we are using this base class in any derived class, so suppose right side I have created one SQL Server connection class, okay? And here I have just using this, I'm inheriting this base class database connection. So here if you see, we have created 4 methods. So one is the connect, the second one is the execute query, the third one is the disconnect, and the last one I have created additional method. So for connect, like I'll just implement the SQL Server connection logic. Here I'll just execute query, I'll just add the SQL Server query execution logic. In the disconnect, I'll just add the SQL Server disconnect logic, okay? But here if you see that I have additionally implemented one more method like additional method, and from there I'm just throwing one exception, new invalid operational exception. So this is breaking the Liskov substitution principle. It states that we should avoid throwing an exception from the derived class which is not the part of the base class, okay? So if you see in the next slide, so this is fine, like in database connection we are using connect, execute query and disconnect method, and in the SQL Server connection also, like we have implemented the base class database connection. Here we are just using connection, execute query and disconnect, right? And here I'll just implement the method. So this is following the Liskov substitution principle, okay? So now let's go to the code and then we will understand. So here you will see that this is my database connection class, and here I have implemented 3 methods, okay? So one is the connect, execute query and disconnect. Same method what I'll use in the derived class. So for that I have created one SQL server connection, and here I am using this database connection. I'm inheriting this. And after that you will see, right, I have just written the logic for the connect. I have created one method for the connect, execute query, disconnect, and here we can implement our logic, right? What is the connection required for the SQL, okay? And if you see here, so this is the violating the principle of Liskov substitution, okay? So from here I am just throwing this exception. So this is not a correct thing, right? So what we will do, we will just delete this. Now it will follow the Liskov substitution principle, okay? And if you want to use this SQL Server connection in your program class, then what we will do, we'll just create one instance, and after that we'll just call all the methods, okay? I'll just delete this one because this is not required now, okay? So I hope you have understand the Liskov substitution principle. Now we will understand what is interface segregation principle. It states that a client should never be forced to implement interface it doesn't use. That means a class should only require to use the methods that are relevant to its functionality. Okay, so suppose this is my interface, electronic device, where I have implemented 4 signatures: turn on, turn off, play music and browser internet. And the right side I have created one basic watch class, okay, where I am just using this interface. And here I need to use all, forcefully I am using all the methods, right? Turn on, turn off, play music and browser internet. In basic watch, we hardly get this functionality of the play music and browse internet, right? So this is violating the interface segregation principle. Okay, this may be a good example for a smart device where we can use this all methods, right? Turn on, turn off, play music and browse internet. But this is not suitable for the basic watch. So how we are going to resolve this? What we will do, we will just break down interface into different parts and use whenever it is required. Okay, so I have just divided, like I have just break down my interface. So I've just created one separate interface for iPowerable, okay, where I have implemented two methods only, turn on and turn off. And here I'm just using like in a basic watch I need to use only one interface, iPowerable, where I'm just using turn on and turn off. Okay, so let's go to the code and then we will understand. So firstly what I have done, that if you see that I have electronic device, right, where I have just implemented 4 methods, like turn on, turn off, play music and browse internet. Okay, and in the basic watch I've just created one basic watch classes, right? Here I'm just using all the functionality, all this method I'm using that forcefully I have to use since I have just implemented interface. So this is not a correct way, right? So earlier I had like turn on, turn off, play music and browse internet. I've just divided now in the music in the iMusic player. I've just created one method, like play music. Here also I've just created two methods like turn on and turn off. Okay, and here I've just created one method. So now we will use according to our need. Okay, so what we will do, we'll just go to the basic watch functionality, and here we need not to use all these things, right? So what I'll do, that I'll just use two methods, like I'll just delete these two, and since I am using two methods, so I need to use this interface iPowerable. Okay, so now we are following this interface segregation principle. Okay, and for the smartphone, right, like for a smartphone, like we can use all the interface, like we can inherit all the interface, right? Since we need all the functionality, turn off, turn on, play music, browser, internet. Okay, I hope you have understand this. Now we will understand that what is dependency inversion principle. This states that high-level modules should not depend on low-level modules. Both should depend on abstraction. That means this should not be tightly coupled. Okay, this should be loosely coupled, like high-level module should be loosely coupled, okay, with low-level module. And it's also encouraged that use the interface or abstraction class, okay, so to define dependencies, allowing for more flexible and maintainable code. Now you can see I have created one class, database connection. Here I have created three methods: connect, execute query, and disconnect. And right side is my high level module, right? Database, data access layer is the class name. And here directly I'm calling this method, like database connection. You can see here, right? Database connection I'm calling, and inside this constructor I'm just initializing this method. Okay. After that I have created one method, get data. Using this database connection, I'm calling all the methods: connect, execute, and disconnect, right? So you can see this is high level module is totally like highly dependent on the low level modules. Okay, suppose today is the database connection, suppose this is SQL database connection. Tomorrow I have to use MySQL database connection. For that, what I have to do, I have to make changes in high level module. Let's see this slide. So suppose this is my MySQL connection, right? So again, I'm just making this, I'm just creating one more instance here, right? New instance I'm just creating for MySQL connection. So here I'm just making changes in high level module, right? So this is breaking dependency inversion principle. Okay, now we will understand how to resolve that. So it encourages us to use like interface or abstract class. So for that, what I have done, I have just created one interface, iDatabase connection, right? Here I've created three methods: void connect, void execute query, and void disconnect. After that, what I have done, I have created one class, database connection, right? Here I'm just calling this interface, and after that I am just implementing all these methods, right? Connect, execute query, and disconnect. After that, what I have done, I have just created one database access layer, right? Here I'm just initializing this interface. I'm not calling any class, like I'm just initializing the interface. And after that, inside this constructor, I'm just initializing, okay, this interface. And inside this get method, I'm just calling all the methods: connect, execute query, and disconnect. So here, if you'll see that directly, I'm not calling any class. So tomorrow, like if I'll just change with the MySQL database, what I have to do. So here you can see like interface would be same, right? I'll create one more class, MySQL connection, right? And I'll just call this interface, and after that I'll just define like all the methods. And in data access layer, I am not changing at all, no changes is required, right? So how you will call? So suppose like I need to call the data access layer, how you are going to call that? So in the main method, like if you'll see here, I'm just using the database. I'm just calling the database connection, right? For the iDatabase connection, I'm just calling for this SQL database. And suppose for MySQL database, I'm just calling MySQL connection, right? So if you'll see here, I'm just database connection I'm passing here. So I'm not changing any high level module. I'm not changing any high level module through interface. I'm just doing everything. Okay, so this is like what dependency inversion principle state that, right? We need to use interface directly, we need not to use any class, okay, because that will violate the dependency inversion principle. I hope this is clear now.